I'm your host, Grayson Brulte. Welcome to another episode of SAE Tomorrow Today, a show about emerging technology and trends in mobility with leaders and innovators who make it all happen. On today's episode, we're absolutely honored to be joined by Alexis Jortson, Vice President, Government Relations and Communications, Redwood Materials. On this episode, she'll discuss battery recycling and the circular supply chain for electric vehicles. We hope you enjoy this episode. Alexis, welcome to the podcast.
Thanks so much, Grayson. Happy to be here today.
Excited to have you here because Redwood's innovating. You're rebuilding the future. You're recycling. You're doing battery components. You're playing a very critical role in the complex, messy EV battery supply chain. And I'll make it very simple. You're trying to make it nice. You're trying to make it cleaner and make it more sustainable. Let's go back to the early days. Why was Redwood founded? What did JB see in the market?
Thanks. I mean, our founding story really does go back to JB and to his experience building and scaling Tesla for about 15 years when he was there as chief technology officer and co-founder. And during his time, on the later half of his time at Tesla, he actually moved up to Northern Nevada, where we're headquartered today, and built and scaled the first gigafactory. And the Gigafactory was the first lithium-ion battery cell facility to come online, really anywhere at scale outside of Asia. And when the factory came online, it actually doubled the world's capacity for lithium-ion cell production. So prior to the Gigafactory, the total output of lithium-ion battery cells in the world was about 34 gigawatt hours annually. Well, Tesla's Gigafactory came online at about 35 gigawatt hours annually. And so just a tremendous feat in terms of the scale of that facility, which really helped to localize battery cell production and also drive down costs through economies of scale. Now, there were sort of two issues, though, that were top of mind for JB when he was building that facility and seeing the scale at which they were producing cells. The first one of those was that all of the batteries that they were producing needed a place to go at end of life. And so that was something that really was sort of top of mind for him, was both the problem, but the opportunity to recover and recycle those batteries. And I can get into why that's possible and just sort of the beauty of lithium-ion batteries and the ability to recover the metals that are inside of them. But additionally, that the Gigafactory and other facilities like it all over the US that were being announced were sourcing components overseas. And so while cell manufacturing was happening there, the bulk value in the battery, the components that really house all of those critical minerals, the anode and the cathode, were being imported. They were still all being produced in Asia. And those two components combined, as economies of scale were helping the Gigafactory to actually collapse the cost of cell manufacturing, meant that the bill of materials in those two components were actually becoming larger and larger pieces of the equation, right? And so if they were going to continue to collapse cell costs and increase the sustainability and make sure that we were addressing any geopolitical and supply chain risks, you had to onshore the production of those two components. And so JB left Tesla in 2019 to focus on building Redwood Materials. And that is what we do. We are a battery component manufacturer that is producing anode copper foil and cathode active materials in the US at scale for the first time, and using an increasing amount of recycled content to build those components.
I'm curious, how do you recover the metals? Is it a Wall-E like creature that goes in there and pulls them out manually, or did you invent a technology? How is it done?
We did. We invented a technology, and we have quite a complex flow sheet depending on the feedstock that comes through our door. So we see all types of batteries that come in for recycling, things like end-of-life electric vehicle packs to smaller electronics, consumer devices like phones, tablets, AirPods, electric toothbrushes, power drills. And then there's sort of a third bucket, which is production scrap from these gigafactories, factories that produce battery cells. Even the ones that are extremely efficient have a tremendous amount of waste at the scale at which they're producing, right? So even if their output is extremely high, if it's 90, 95%, well, if that's a 30, 40 gigawatt hour facility, that still amounts to truckloads of material that does need to be recycled. So that's sort of the third bucket that comes through our doors. And then all of those feed streams enter into very material-specific recycling, ultimately going through a water-based hydrometallurgical process where we create products that then can go directly into our anode copper foil and PCAM for cathode production.
Battery toothbrush is interesting. Most people, okay, it died, it goes in the garbage, and then bye-bye it goes. How can a consumer say, okay, I'm going to throw this thing out now, I want to do the right thing, I want it to have a second life. How can they ship it back to Redwood?
It's so funny. It was not initially one of our huge focuses, but something that really came to mind quite early in kind of building the company, Grayson, because we recognized that, while we were working mostly with other businesses to consolidate and collect these batteries, there was this gap that you sort of just identified, which is that consumers really didn't have pathways to get this material recycled. Everyone knows that they probably shouldn't throw it into their trash can. It shouldn't be household waste. And yet there aren't very clear pathways. So one of the things that we launched about a year ago is our consumer recycling program that allows people to recycle their lithium-ion devices and rechargeable batteries. And they can do that a number of different ways. They can mail it directly to us, or they can meet us at an event around the country. We host events almost every single week around the US, with many of which are in partnership with Rotary clubs. And we have tents that are basically pitched. I'm always blown away by how many people will come on a Saturday or a Sunday with their kids post-soccer practice in the minivan with boxes of old rechargeable devices and lithium-ion batteries, because they really care about doing the right thing. And they've basically stockpiled these batteries in a junk drawer for years and years and just haven't had a place to get rid of them. And then the third is our drop bins. So we actually have partnerships with Audi and Volkswagen Group of America to have Redwood recycling bins in many of their dealerships across the country. So you can actually walk into some of those locations and drop off your batteries there. But yes, it's a huge problem and a huge opportunity. And today, a big part of why only about 5% of these consumer devices are recycled, because these pathways just have not really been established, and there's not enough education.
You're right about not enough education, but let's put economics into this. If I'm a consumer, you say, oh, you can get a tax deduction similar to Goodwill, or you're writing off a gambling debt. Do we get to the point where you're donating lithium-ion batteries, you can get a tax deduction? I'm asking that on the premise that it's going to become a very big national security issue, especially as we transition to an all-electric future. We're going to need batteries. We're going to need the recyclability. Do we get to the point there where perhaps you get a tax deduction for donating it?
It would be a really smart way to continue to incentivize this. And it's certainly something that we've thought about as we think about how do we pull these levers, how do we increase the pathways of collection for consumers. There's a lot of low-hanging fruit out there already with people that just really care and that want to be able to spring clean. But certainly, the U.S. is in this we're in a really fortunate position in the sense that, a lot of these metals that make up these batteries are not native to this country. We are heavy consumers of these devices. And so we have a lot of batteries here that are stockpiled away. Actually, some of our own napkin math is that, perhaps the largest lithium and cobalt mines anywhere in the Western Hemisphere is housed in America's junk drawers. And so how do we tap into that? How do we make sure that we're recovering those materials, getting it back into circulation here in the U.S., because we do have this tremendous strategic resource?
The government, the Congress, the president signs the Tax Reduction Act, and all of a sudden the accountants, oh, you need a tax break, go through your drawer, start going. And that helps from, as I said, a national security perspective. So that's one element of it. Then you have the traditional industrial aspect of it. Bringing us together, what is the current state of battery recycling today? It's obviously an emerging industry, but where does it stand today?
Yeah, so the battery recycling industry is still very much in its infancy, in the sense that if you look back to maybe even 5 years ago, there really weren't any companies, and today we have a number of different startups that are focused on this. So that's really exciting to see. Redwood today is receiving about 10 gigawatt hours of lithium-ion batteries annually. That would equate to about 40,000 metric tons a year of material that come through our doors that we're processing. And we can recover, north of 98% of the critical minerals from batteries like nickel, cobalt, lithium, and copper already, and then remanufacture those materials back into battery components. But, the industry as a whole is still relatively new. And, one of the things that I always really like to stress is that while recycling is so incredibly important for the future of electrification and sustainability, if you look at the demand for lithium-ion batteries over the next decade, we're looking at about a 500% increase in demand for batteries for both electric vehicles, for clean energy storage. And then, of course, we can't discount the fact that people are still going to need to consume more and more consumer devices. We're going to need more AirPods and laptops and iPhones. And so it's really, really critically important that we also balance expectations around recycling with the need to continue to mine, because we simply cannot recycle our way to a 500% demand for this material. Now, our vision and belief is that down the road, when we sort of hit a plateau of these products, so we're no longer turning over an internal combustion for an electric vehicle, rather we're replacing an electric vehicle with an electric vehicle, you'll hit this plateau where we will not need to mine as much. But we've got a long way to go. We've got to get these metals out of the ground first, and then from there we can nearly infinitely recycle them.
We have to mine today. As an investor, I'm worried that the mine companies will get drunk on their profits and cut back on mining, but they have to continue to mine to meet the demand. We're seeing what's happening with Glencore. We're seeing what's happening with Trafigura there and the prices. So that's on the mining trading side. On the recycling side, when does a Waste Management or Republic Services, when do they start to enter this and say, wait a second, okay, we're started by the Huizinga family for the waste management. Hey, there's a growth opportunity over here. Look what Redwood's doing. We want to go in there. When do you get more of those traditional recyclers stepping into this industry?
We've actually had a lot of conversations with some of those traditional recyclers. I think, it's quite different than their business today, right? And actually, these lithium-ion batteries pose a lot of risk and a lot of danger to some of those traditional recycling streams. Those companies really don't want lithium-ion batteries to end up in their streams. And as a matter of fact, that's why there are rules that you shouldn't put them in the trash, because they don't want to take them. So we actually work with a number of those kind of waste management companies in order to take batteries that do end up in their waste streams so that they can be responsibly and safely recycled.
And that becomes a win-win situation. They recycle bottles, cans, and boxes, and that's what they do very well. And you recycle lithium-ion batteries and helps secure the supply chain. There's a lot of debate. President Biden signed the Inflation Reduction Act. What impact is that having on the industry?
Look, I think the Inflation Reduction Act has, really, at least the way that Redwood looks at it, just kind of, strapped a rocket ship to the back of this industry, right, in many ways. The parts of the law in particular that are very focused on electrification and battery manufacturing really aim to localize and onshore as much of the supply chain as possible. In particular, there's the electric vehicle or clean vehicle tax credit, which provides a $7,500 tax credit to consumers of electric vehicles that meet some of the requirements in terms of supply chain localization. So the first half of that credit requires that they source critical minerals from free trade countries, as well as a couple others that have been added to that list, to receive the first $3,750 of that credit. And then the second half requires that they manufacture battery components in the US. And so that, really what that did was it uncapped what was previously an electric vehicle tax credit that was about to sunset for many automakers, and it was not contingent on any supply chain requirements, and said, we'll uncap this so that you can go beyond the 200,000 units that was the original cap of the original credit. But the supply chain needs to be localized and secured, and we need to be working with some free trade partners. And then the second piece of the IRA that is incredibly beneficial are the production tax credits that maybe don't get quite as much attention, but there are production tax credits as well that, when it comes to battery production, are quite tremendous. There is a battery cell and battery module production tax credit. For battery cells, it is a $35 a kilowatt hour credit, which, if you look at the cost of producing battery cell, somewhere in the $100, $120 range, that's quite significant. Then there's a similar 10% production tax credit as well for battery materials, battery components, such as anode and cathode that make up those cells, right? The real kind of bulk of those cells. So, those two parts of the law combined are really going to be tremendous in terms of just jump-starting and localizing the supply chain here.
How do we flatten the supply chain for EV batteries or shrink it? It's very complex, and I'll use a nice term. A lot of interesting characters involved in the supply chain. That's probably the most interesting, nicest word I could say. How do we shrink it, make it more efficient, and from an environmental perspective, make it less carbon intense? Because if it's mined in Africa, and then it goes to China and refined, and then it gets shipped to either South Korea or gets shipped to America, or then don't forget we still have all the stuff coming out of Australia. It's very complex and it's very carbon intensive. How do we flatten it and shrink it and make it more sustainable, more optimized?
It's a great question, Grayson, and it's really kind of one of the questions that prompted our founding and that really drives our mission, which is, the current global supply chain for batteries is about 50,000 miles. It's really a mess, and you can't really help where these metals, originate, right? They come from various different continents, lithium from South America and cobalt from Africa, and you can get nickel up in Russia historically, and also in Australia and in other parts of the world, Canada. But it's really a challenge because you have to mine all of these materials all over the world. Then historically, metals refining has really happened mostly in China and in Europe. And so then they have to travel from wherever it was that they were mined, to these places to be refined. And then from there, in this example, for cathode production, you're then sending them to Asia, which, mostly all of the cathode produced in the world, which amounts to, about 65% or so of the value of a battery cell, is happening in either South Korea, Japan, or China. And so that is kind of the final step until you hit cell production. So then you've got cathode in Asia, and now it has to make another trip halfway across the world to the US for cell production. So this was one of the things that really early along, JB looked at and said, we have to figure out a way to collapse the supply chain. We have to be localizing this because it is a big risk to the US's ability to really scale battery cell production if we are so dependent on these components that are being manufactured pretty much entirely in Asia. But then also, every single one of those lines connecting all of these different countries from mining to refining to battery component manufacturing all the way back across the world to cell production in the US, represents a huge carbon footprint as well as cost. Every single time these materials have to get on a boat or a plane, it costs a lot of money as well. So being able to really collapse and localize that is our goal and our mission at Redwood, making sure that all of that is happening in one place in the US, and that we can infinitely recycle and recapture these materials at the end of their life and keep them in circulation here in the US.
That's well said. We've learned this lesson with semiconductors in Taiwan because of geopolitical issues between China and Taiwan. We're not going to get those today, but we're learning that lesson with semiconductors. If an escalation happens, the world economy has to come to a grinding halt. We can't let that happen. With EVs, we have a lot of mining in the Salton Sea in California. There are lithium pockets in the United States outside of the junk drawers and millions of households around the United States. Do we get to a point where a company looks to be vertically integrated? They own the mine, they own the refining, they're making the battery, then they're shipping the battery pack. Does somebody say, okay, I'm going to build a national security first company, I'm going to vertically integrate this in the United States? Do we get to a point somewhere along the line?
I mean, we certainly could. I mean, I think if you look at sort of at Redwood's, business, we're not doing mining, but we are doing recycling, refining, and then component manufacturing. So we're stopping short of cell manufacturing and then not doing the front end mining. But that vertical integration is really critical. It's a really important part of this.
It's a very important part. The recycling is fascinating. That's what you're most famously known for. That to me is your brand in the market. But I'm very happy you're sharing about what you're doing with battery components. I'm really curious. What is the degradation like when you recycle a battery? Are you able to hold 80%, 90% of the initial charger, or what does that look like?
It's actually quite phenomenal, and I think that recycling as a whole, kind of the concept of recycling commodities in general, people tend to think that you're kind of downcycling, right? That there's somewhere along the line you're degrading the efficiency or performance of whatever the commodity is that you're recycling. That is not the case with these metals. And, that is what is such an incredible opportunity with battery recycling. Not only can we recover such a high percentage of the metals already in our technology, so, 95 to 98% of that lithium and cobalt and copper and nickel, but the performance of those metals does not change. So, and actually, Argonne National Labs recently did a study that they released and was reported on, showing that actually, in fact, they took Redwood recycled content and built, produced some cathode out of it and then put it in battery cells and tested those. And if anything, in some cases, they performed better. Now, why is that? It's because every single time this is going through the recycling process, it's almost as if you're filtering these metals again, right? So they have these little impurities from the earth in them, but you're kind of refining them again, and you're sort of removing, potentially any of those other little deposits that would be left, and if anything, they maintain their performance, or in some cases might increase it. And really, the reason for that, Grayson, is a metal atom doesn't cease to be a metal atom, right? You take a nickel unit and you put it through a recycling process, and that atomically is not changing in any way. And so there's just incredible opportunity to be able to truly, almost infinitely, recycle this material.
Recycling process sounds like you're going to the spa. You're coming out rejuvenated. So you're taking the lithium today, it's going to the spa, which is your recycling process. It's coming out refreshed and relaxed and supercharged, ready to go. Is that a fair way to look at this?
I think that's a fun way of looking at it. I think that's absolutely a fair way.
When you're recycling, you mentioned, I'm fascinated with the electric toothbrush. I have one and I like it. It does my 3 minutes, and every minute it beeps. Do we get to the point where in the future there's a battery pack in a car where you have a piece of an iPhone, a piece of electric toothbrush, an iPad, an AirPod? Do we get to the point where all those materials are in a battery pack for electric car in the future?
Absolutely. And I think we're pretty close to being there. That's the other incredible thing about these metal units. They don't know if they came from a phone or a laptop or a toothbrush, previously, and they don't really care. You can take those metals and put them into an electric vehicle or into energy storage down the road, and it doesn't really matter. So there's really a tremendous opportunity. The other thing with that is that these lithium-ion batteries, in many cases are quite similar, but the chemistry of them, they're similar, I should say, in terms of the metals that they use, but the chemistry of them is quite different. So, for example, some of the older chemistries have just proportionately different percentages of some of these metals. Similarly, a smartphone, for example, has 30% cobalt. An electric vehicle, at this stage, the electric vehicles that we're making today have just a small fraction of it, because chemistries have evolved and changed, and because you need different types of metals at different ratios for performance factors for whatever the lithium-ion battery is powering. So there's a really incredible opportunity to basically take, if you look at kind of the feedstock that comes through our door, to take different devices to be able to get the metals that we need to be able to produce those downstream battery components. So, for example, if you look at smartphones, at like an iPhone, for example, you need something like 7,000 of them to get the lithium that you need for a new electric vehicle pack, but you only need about 166 of them to get the cobalt that you need for an electric vehicle. So there's also just a really incredible opportunity to be looking at different lithium-ion batteries and feedstocks, which is what we do, what comes through our door, and being able to recognize that we can pool different percentages of metals from those to be able to then go downstream to build battery components for electric vehicles and energy storage.
What do you deliver to your customers at the end of the day? Let's just say I'm Acme customer. Hey, Redwood, I need lithium ion, I need batteries. What do you deliver to your customer at the end of the day?
So our focus is on two main battery components: anode copper foil and cathode active material. And so those are really kind of the two core components in a battery cell. Combined, those components, make up the significant percentage of a battery. It's about 80% of the cost of a cell and about 15% of the total vehicle value of an electric vehicle. And those components today have not been produced at any scale in North America. And so those are the two components that we really focus on producing and sending to our downstream customers, which are cell manufacturers, so that they can source them locally in the US and from an increasing amount of recycled content that are in those components that we produce, rather than having to source them overseas.
The energy storage business, in my opinion, is going to be, it might even grow faster than the electric vehicle industry, just based on demand for energy. And if you look at everything happening, at least where I live with hurricanes, we need battery backup storage because of power issues. Will that start to act as a big catalyst for your business, the growth of energy storage?
I think it absolutely will, and it's a big focus of ours as well. So much of the conversation is around electric vehicles, and I think it's also easier to sometimes equate, the amount of material we're handling or the components that we're creating into what, how many electric vehicles does that produce? But in no way is the focus solely on electric vehicles. We are also producing components for energy storage because it's a really, really critical part of a sustainable energy future.
And you look at an individual that's going to put battery storage in their house, they're going to put something in their house. And let's use the example, when you buy a refrigerator, it's got the Energy Star for energy savings. Do we get to a point where there's a Redwood recycle, there's a Department of Energy that X amount of this material has been recycled? Do we get to the point where it's standardized and it's badged? The consumer knows, wow, this is really good.
We certainly would love to see that future. And I think that's a really important part of it too. I mean, if you kind of think back onto some of it still is a conversation today, but consumers really do care about what it is that happens at the end of life to many of their products. And, I was at Tesla previously, and obviously this was something that came up with JB quite frequently too. But, a lot of customers, we were always surprised, asked about what would happen at the end of life for their batteries. It was a big part of kind of, I think, getting the wheels turning in JB's brain around making sure that we had a plan to recycle and recover this material, because it really also matters to consumers too. And there's obviously just such an incredible opportunity to sort of infinitely do that. But it is really important to people. And, we're hearing that, we're seeing it firsthand, right? With people that care about the consumer program, that care about having recycled content in their electric vehicles in the future, and that are asking questions about that. So I think it is a really important part of continuing to drive this industry, is just consumer demand for more sustainable products.
How are the OEMs that are manufacturing electric vehicles going to figure out the recycling process? Because some individuals buy the vehicles, some individuals lease the vehicles, the individual that buy the vehicle then perhaps could go and flip it to a used car dealer or flip it to a friend. How are they going to manage that process to extract the value out of the battery? It's a complex, controversial, but there's a lot of value left at the end of your lease.
There is, absolutely. And we're working with a number of those automakers, already on recycling deals. So the way our partnerships, kind of work or are structured today, they're very unique depending on the partner. But for our automotive OEM partners, like Volkswagen Group of America, Audi, Toyota, Ford, Volvo, we have a number of them. The partnerships are often to help to source these batteries at end of life. Now, cars at end of life don't typically go back to the producer, right? I mean, if we kind of look at the internal combustion engine and how the end of life kind of flow has worked with those vehicles already, they typically end up at scrapyards. They go through dismantlers. So in many cases, we're actually out there working directly with dismantlers to source these batteries. And we have a front-end business that really goes into the field, that safely packages and transports these batteries back to our facility, working in partnership with many of these dismantlers. Obviously, batteries will also go back to automotive dealers if they need to be swapped out, or if there's an issue or a vehicle's totaled, sometimes they end up there. So we work with dealers as well. But largely our partnerships are with these OEMs to figure out how we consolidate and get these batteries back and recycled. And these OEMs are really seeing the strategic opportunity of working with a company like Redwood, because they're looking down the road as well and recognizing that there is going to be a need for a ton of metal. Right? They're going to need a lot of these elements back in their supply chain in order to build the cells that they've all committed to building for their electric vehicle platforms going forward. So they see a really strategic opportunity both on the front end for recycling, but also downstream in battery component sourcing to work with us on both ends of that equation and ensure sort of both a circular but also a more stable supply chain.
How do you get the battery out of an electric vehicle? The dealer goes, the battery pops down, and then it gets shipped off. I'm going to use a very simple term. It gets FedEx to Redwood. Obviously, that's not probably the case. But how does that whole process work when a dealer says, okay, here's electric vehicle one. Okay, Redwood, we're ready. How does that whole process work?
Yeah, there is quite an established dismantling process that already happens that's been in effect for many, many, many decades, right, from the internal combustion industry. And it's not that dissimilar. Of course, when dealing with an electric vehicle, you need to make sure that, obviously there are a lot of kind of safety requirements and different approaches that you need to take when handling a massive high voltage lithium-ion battery. We're actually out there in the field and many times working with these dismantlers and helping to train them too or share best practices on this. We have a field team that's out there in junkyards with them, literally dismantling some of these cars sometimes. And then, we put them into really safe and secure packaging. So sometimes oftentimes that looks like a big wooden crate. And then we ship it by truck back to our facilities.
How big of a fire risk is it? Do you have to put fire retardant? Do you have to make special, you mentioned wood, do you have to make special boxes to ensure the safety of when that truck is transporting the batteries back to your facility in northern Nevada?
You do, absolutely. Yeah, so that's a big component of this as well, is making sure that you're transporting very safely and in line with DOT regulations on this. And so, and if a battery is damaged or defective or recalled, then, there are different requirements in terms of packaging and transport as well that play a role in that. But it is, highly complex. And one of the big areas of focus for us as well is, how do we keep this as safe as possible and also make sure that we're able to help scale this industry so that we can be recovering batteries and getting them, effectively and efficiently back into recycling stream.
Well, your founder and CEO, he seems to strive at complex problems. Look what he did at Tesla, scaling that company, build a battery technology, and now he's building the battery recycling. So he clearly understands complex problems and he makes businesses out of them. So go Team Redwood, go JB for that one. Alexis, how do you see the future of battery recycling from the market perspective evolving and maturing? Obviously, we're seeing on the autonomous side consolidation, the EV side, we're going to probably have some consolidation at some point. Where do you see the battery recycle market evolving to?
Well, I think, one thing that we know for sure is that every single year there are going to be more and more electric vehicles retiring from our roads, right? I mean, if you sort of look back historically on when electric vehicles really started to ramp, we really were only introducing the first EVs to roads a little over a decade ago. And so we're just sort of hitting that point where kind of that first wave of electric vehicles are starting to retire from the roads. But we know that every single year, as more and more EVs are hitting our roads, we can kind of look 10 to 15 years down the road and predict when it will be that they will retire and need to come in from recycling. So we will have more and more to recycle every single year. And then in the meantime, a ton of production scrap as more of these battery cell factories come online all over the country, right? I think there's been close to 800 gigawatt hours worth of battery cell production announced between now and 2030, something like that. I mean, just an incredible amount of battery manufacturing capacity. If you think that the Tesla Gigafactory, which is still the largest lithium-ion battery factory on Earth, is about 40 gigawatt hours, 800 is just incredible. So, scrap from those facilities. And then, of course, looking even further down the line at kind of what the projections are for electric vehicle sales and where all of those cells that we're manufacturing are going to go. The U.S. and this administration is really focused on hitting 50% electric vehicle sales by 2030. So we have a lot of material that is coming. But maybe more importantly, or just as important, is making sure that we have the components as well to be able to actually build those cells and make sure that this industry doesn't have significant bottlenecks along the way, as kind of you pointed out with the semiconductor and solar challenges that we've had in the past, making sure that we don't repeat those mistakes and that we really have thought about how to secure our supply chain and prepare for this really steep ramp.
One thing's very clear from this conversation, from what you've explained, Redwood's clearly prepared for where the market's going. You're clearly prepared for the demand. And you have the expertise to do it. In your opinion, what is the future of Redwood materials?
I think the future of Redwood is making sure that we can scale the production of these critical components, and that every single year the percentage of recycled content inside of these components is increasing as well. And so, that's a really, really important part of our mission. Today we made a decision that ultimately the production of anode and cathode and the need for those materials here in the country, should not be gated by the amount of recycled content that can come through the door. We're aiming to produce 100 gigawatt hours of both of those products. So that would be enough for about 1 million electric vehicles a year by 2025. Now, that's a breakneck pace, but that's really what's critical if you look at how many battery cell facilities are coming online in the U.S. And, their only game plan is to continue to source those components from Asia for the time being. So that is kind of our, somewhat, I guess, near-term, however you look at it, relatively long-term plan is 100 gigawatt hours by 2025, and then continuing to scale from there. And then, further out down the road, of course, getting to a future where we're infinitely able to just recycle this material without having to bring in any virgin material to hit that demand.
You offer a solution to allow electric vehicles to scale while keeping national security intact. That's the big emphasis there. You're keeping national security intact. Alexis, as we look to wrap up this insightful conversation, what would you like our listeners to take away with them today?
I think, really just the importance, Grayson, of localizing as much of this as possible. And I think there's a really bright future in our ability to recover such a high percentage of these metals that can be infinitely recycled. I think if we're looking at the transition to sustainable transportation and a clean energy future, there's a lot of work to do on the front end to get us there, to make sure we have the supply chain, to make sure that we have the metals mined. But there's a really, really bright future in the fact that you can just continue to recycle these materials and keep them in circulation. So I think that's really a critical part for people to understand is just the opportunity to achieve true circularity with batteries. But then, also the importance of really localizing this, which we continue to talk about for national security reasons, for sustainability and carbon footprint, being able to drive that down as much as possible. And then cost too. I mean, it's such a critical part of being able to get electric vehicles to as many Americans as possible, is to continue to drive down the cost. And when you really look and kind of zoom in on what is impacting cost of electric vehicles today, it comes down to batteries. And then if you zoom in further on batteries, it really comes down to the bill of materials and these components that are really still impacting the cost. And so localization, recycling, collapsing that supply chain so that they're not having to travel quite as far are all ways that we can help to continue to reduce costs.
Localizing the supply chain, recycling batteries, yes, it's a brighter future, but it's also a cleaner future. Today is tomorrow, tomorrow is today. The future is Redwood Materials. Alexis, thank you so much for coming on SAE Tomorrow Today.
Thank you so much, Grayson, for having me.
Thank you for listening to SAE Tomorrow Today. If you've enjoyed this episode and would like to hear more, please kindly rate, review, and let us know what topics you'd like for us to explore next.
Be sure to join us next week for another episode of SAE Tomorrow Today Unplugged, where I'll share my candid insights on the future of mobility.
SAE International makes no representations as to the accuracy of the information presented in this podcast. The information and opinions are for general information only. SAE International does not endorse, approve, recommend, or certify any information, product, process, service, or organization presented or mentioned in this podcast.